over here. Come on. See this. Get some of this. Can you hear me? We'll hear in the chat in a second. Yeah, come on. See this. So, sound check is done, and we're going to be going for 2.5 hours, 2 hours and 30 minutes. So set the timer, put it aside. I need that for my phone, to be honest. For my laptop. Oops. Oh no, not the there we go. Oh. Oh, I finally got that. God. Suffering with all day. We need to get a nicer thing out here. But anyway, right. No hiccups this time. Looks like everything is finally in a good place. Everything's sorted. So, let's see who is on. So people out in the chat. Hope you're doing well. Give a shout out if if you're watching, you're having fun. Well, we're way behind tonight, so but we still got 2.5 hours, so let's crack the back of this. We're on, I think to us, this might be short night stuff because we're on decorators now, and there ain't a lot of lessons in this, so I think we'll get through decorators, some types, and then we'll do all our little celebrations. Hooray, we passed it and stuff, before we get into like Twitter, LinkedIn, all that stuff. So we're back on functional programming, Boot.dev. Gonna smash it out, and then the next course next week will be, and I think there'll be less nights next week because just busy and got a few things. Start cooling next week. It's going to be build a static site generator, and then we're getting there. It's April, and we'll have got through 8. So like we're not quite halfway. So I think we need to speed up a little bit. Maybe we get through these faster because they're going to be. Say that. Look at that one. That one's not going to be faster. Yeah. Okay. Maybe we had early wins up here. We got through things quite quick. These next ones might not be so fast. But it is not a challenge if you know you can do it. So let's get back to it. Right, let's smash this out tonight and then we'll be done. So just maybe just a short one tonight if you're watching. So we're on to decorators in the functional programming part. Okay, lesson 1, decorators, chapter 8. So decorators, Python decorators are just syntactic sugar for higher order functions. So we have this function, val counter, and it wraps another function. And then we have this at val counter. And then a process start function, process start what? File count 1, document what? So where does this take? Function to decorate. Okay, not quite following this. So val count 1, document what? Wonderful val count, 5, a document, yeah, so, okay. So the val counter line is decorating the process start function, and the val counter function is decorating the process start function with the val counter function. Val counter is called once when process stock is defined with the at syntax. But the wrapper function that it returns is called every time process stock is called. But the wrapper function that it returns is called every time process stock is called. Let me read that again. So the val counter line is decorating the process stock function with the val counter function. Yep. Val counter is called once when process stock is defined with the at syntax, but the wrapper function. Oh, val counter is called once when process stock is defined with the at syntax. But the wrapper function that it returns is called every time process stock is called. That's why val counter is preserved and printed after each time. Okay? It's just syntactic sugar. Python decorators are just another, sometimes simpler way of writing higher order functions. These two pieces of code are identical. So with decorator, at val counter, define process stock, print f document, blah blah blah, process stock, something wicked this way comes without decorator. So same thing without the decorator. Okay. So you call val counter with the process. Okay. For closures, right? So assignment. Provide the provided file type aggregator function is intended to decorate other functions. It assumes that the function it decorates has exactly 2 positional arguments. Create a process stock function that's decorated by the file type aggregator. It should return the following string. Processing dot blah, like that. Where doc and file type are its positional arguments. See line 11 for where it's being called. So create a process doc function that's decorated by the file. So at file type aggregator, and then define was it process. Let's go doc file. Let's go type. Whoops. Whoops. Pull this up a little bit, can't really see what's going on. So why did it fail? So inputs, welcome to the jungle, txt, expecting this and this, processing doc, welcome to the jungle, file type X, actual, got none in tx1, tx2. So it's missing this part. Oh, return, right, okay, so return. That's probably why. Yeah. Yeah. Bit weird syntax, but is what it is. Whoops, not that. Hey. We'll go to the next one. Args and quarks. So in Python, args and quarks allow a function to accept and deal with a variable number of arguments. Args collects positional arguments into a tuple. Quarks collects keyword named arguments into a dictionary. Okay, collects positional arguments into a tuple to a dictionary. So print arguments, args, quarks, positional arguments, keywords, quarks. Print these. Yep. Okay. That's interesting. Positional arguments are the ones you're already familiar with, where the order of the arguments matters like this. Keyword arguments. Keyword arguments are passed in by name. Order does not matter like this. Ah, right, okay. Like a destructuring way. A note on ordering. Any positional arguments must come before keyword arguments. This will not work. Okay. B3, B equals 3 and then 2. Assignment. At doc2doc, we need better internal debugging tools. Complete the args loader function. It takes a variable number of positional and keyword arguments and prints them to the console. Print each positional argument sequentially using numbers and periods as the prefixes. Starting with 1, for example. So going to be args, print, I guess args dot split. Prints to the console. So so I do something like we got a list. Is there any good functions for tuples? Can't really remember, to be honest. So loop over tuples. Right. Oops. I guess for arg in args, we could probably have the index like that, and then we're going to do print and then f string like this. It's going to be index dot space and then arg with a new line like that. Okay. What is it again? Python loop tuple with index. Can we use range, or do you have to enumerate or something? Enumerate. Okay, so we did that. Print to the console. Print each keyword argument alphabetically by key using asterisks as the prefix with the colon in between them, for example. So for quag in quags print, it's going to be f string asterisk space see what it comes out with. Key value, can we do that? This is going to be key. Key value, no, I can't do that. Just forget every time, so loop dictionary. Items. Is that the best way to do it? Items. I don't want to log in. Is that the cleanest way to do it? Fair enough. Okay. Whoops. Yeah, that's right, isn't it? Oh, it's because not start from 0. +1. Submit. No, still not right. Oh, alphabetical order, is that why? Python sort dictionary by key. So how do we sort? Sorted. Huzzah! What was their solution? Was it as clean as ours? I index to organize. All right, they just keep a loop counter for that one. No need for that for us. Yeah, they did exactly the same thing, basically. Peasy, peasy, peasy. Okay, so... Oh, crikey. Okay, the args and quags syntax is great for decorators that they're intended to work on functions with different signatures. Example, the log call count function below doesn't care about the number or type of decorate functions to decorate arguments. It just wants to count how many times the function is called. However, it still needs to pass any arguments through to the wrapped function. Log call function below doesn't care about the number or type of the decorate functions. Func to decorate arguments. It just wants to count how many times the function is called. However, it still needs to pass any arguments through the wrapped function. Complete the markdown to text decorate function. It can decorate a function with any number of string arguments, no matter if they're positional or keyword args. It will run the decorate function, but first strip out any markdown heading symbols. See below for an explanation of markdown headings. It should return a wrapper function that takes args and quags. The wrapper should map the args to a new list where each string is converted to plain text using convert to textmd. Okay, so new list. So we're going to have what is it? Args list equals going to be args. Has it happened with the thing again? Map is like a function used outside, isn't it? Map function iterables. The function and then the args. And what we're doing, we're going to wait, string is converted to plain text using it. Okay. So we're going to say lambda arg And then what is it? Convert to text markdown arg. I think that's done. And then map the quags to a new dictionary. So quags underscore dictionary. Quags dictionary. We're gonna map lambda quag. That's going to be convert to so it's going to be like this. It's going to be key value key, and then like that. I think roughly. Use items dictionary method to pass a list of tuples of key value pairs to the map. Create a function for map which changes the value item the tuple blah blah blah, and then return. Return the result of calling a decorated function with the new arguments. So return func. That's going to be args list quags dictionary, something like that. So args list quags dictionary. How do you get pretty print? So Python print map. Good thing here because that's all I'm doing. Hold on, Python lambda key I. Uh, Python map lambda function tuple dictionary. Oh, okay. Kind of ugly, but like key value, key value. I kind of feel dirty doing this. I'm not great at Python, so you people out there, you have to come and correct me. See what it looks like. Python map to dictionary. I've looked at this one before. Dict. Pretty sure I've done this. Return the result of the calling decorate function with the new arguments. What am I doing wrong? Format is easy. Map cards to a new dictionary. To a new list. Look like that. So map the args to a new list where each string is converted to plain text using convert MD. Yep, done that. Map the quads to a dictionary where the value is converted to plain text using convert blah blah blah. The key should remain the same. Use items dictionary to pass a list of tuples of key value pairs to the map. Create a function for map which changes the value of an item tuple with a... Yeah, I've done that. And then return the result of the calling function. Return the result of the calling function. Decorate function with the new arguments. So I think I need to go like that. And then do... yeah, was that it? Okay, that was a bit longer than expected, but it don't matter. We got through it. Don't think decorators are something I'm going to use very often. How you doing out there in the chat? You doing good? So decorators review. A Python decorator is just syntactic sugar for high order functions. Syntactic sugar just means a more convenient syntax. Not all programming languages have built-in decorators, but most do support higher order functions and closures. Some of the most famous functional languages like Haskell, Erlang Closure, and Lisp do not have syntax decorators, but they do have higher order functions and closures, meaning the decorator pattern can still be used. So if you understand those concepts, they will serve you well in many languages. Function decorators are not widely supported as higher order functions. Yes, true. Function currying, higher order functions, and first class functions are unique to purely functional languages. Unique to Python, unique to object programmers, commonplace in most programming languages. Challenge. 3 challenges I feel like I'm going to absolutely suck at. Configure plugin. Doc2Doc should be extensible to allow for third-party plugins. These plugins will be configurable. Assignment complete. The configure plugin decorator function. It decorates a func that takes keyword arguments quags, but the wrapper function it returns takes positional arguments args. The arguments passed to the wrapper will be a series of tuples, each a key value pair. Convert the args into a dictionary with the dict function. Hold on. It decorates a func that takes keyword arguments quags. Whoop. So wrapper takes args. And then return wrapper. Get result of passing. So convert args into a dictionary. So args dict equals dict args. Get the result of passing this dictionary into the func as keyword arguments unpacked. Get the result of passing the dictionary into the func as keyword arguments unpacked. Return the result. Return func. Get the result of passing this dictionary into the func. Alright, okay, I see. So args dict like that. Return the result. Is that literally it? So function wrapper, positional arguments, path documents extension MD, path documents prefix copy extension MD. Okay, I just did that one. I'm not entirely sure what happened, but I get it. Just not, don't write a lot of stuff that really requires it. So SKHTML, you can stack decorators and you can use currying with decorators. Oh god. Anybody in chat, let me know out there if you use these things on the daily, because I don't. I mean, I'm doing front end most of the time, so I'm not going to need to, but does anybody use them regularly? Like, I don't. And I'd struggle to, I guess, conceptualize where I could use them as well. So you can stack decorators and you can use currying with decorators. So define to uppercase and a wrapper document. Return func document.upper. Return the wrapper. Oh, feed testing. So to uppercase, get truncate currying. Do print input, print input. keep calm and carry on. Prince, keep calm. Ugh, oh my god. Oh my goodness. Okay. Well, I'm hoping we finish this tonight because blimey is throwing some shenanigans at us. Observe that two uppercase get truncate 9 and get truncate 9. Oh, and get truncate 9 returned truncate. Which wrapped print input. Then print input printed keep calm from keep calm and carry on. You might not know anything about HTML, that's fine. This challenge isn't about HTML directly. Just understand that it's a markup language like Markdown. Certain characters are interpreted as part of HTML text. In order to show these characters without interpreting them, they must be encoded as escape sequences. Too long didn't read, replace angle bracket with alt semicolon and lit semicolon. Doc2Doc needs a feature that can take care of encoding such characters for you. This is particularly helpful if you want to show raw HTML on a vanilla HTML web page. HTML even has a semantic pre-tag for designating pre-formatted text. Assignment. Complete the replacer function. It takes as inputs two strings, old and new, and returns a function replace. Replace takes an input function, so we're gonna have replace, and we'll return that. Replace takes an input function, decorated score func, and returns a wrapper function. Define wrapper. Wrapper takes input string text. It uses replace string method to replace. So replace instances of old and new in the text. So text dot replace old new. Then it returns the result of passing the modified text to the decorated func. Replace. Oops. Place text equals that, and then decorated func. Replaced text. I guess return wrapper like that. Use a series of the replacer functions to decorate. Use a series of the replacer functions to decorate tag pre. Pass the following pairs of strings these decorates to encode the escape sequences. Oh, excuse me. So where's my at symbol at? Replacer. So replace that. We have to have single quotes like that, just one, and then one single quote like that. And it's going to be Alt, LT, semicolon, GT, Dragon Ball GT, quote, and then where's this? Hash X27. Dang it. Oh, holy heck, did I do it first time? No way. No way, Jose Bob. I'm a genius. See what their solution was. It's similar or the same? Pretty much the same. Crushing it. Last challenge on this one. Then we go to sum types. I don't even know what sum types are. We'll figure it out together. So, Iru cache. Iru, or is it L? LRU. LRU cache. LRU from the FuncTools module is an example of a decorator, an example of memoization. LRU cache memoizes the inputs and outputs of the decorate function in a size-restricted dictionary. It speeds up repeated calls to slow function with the same inputs. For instance, if the function reads from the disk, makes network requests or requires a lot of computation, and is used repeatedly with the same inputs. Here's an example from a Python documentation that perfectly illustrates how and why to use LRU cache decorator. No previously cached result makes 11 recursive calls. Just looks up cached value result. Makes 2 new recursive calls and the other 11 are cached. Okay, so since factorial function is recursive and the inputs are sequential numbers, it's called repeatedly with the same inputs. Without the cache, the function without the cache, the function would be called 30 times. With LRU cache, the function is only called 13 times. While you don't often need to compute factorials, this example ties together how to use a decorator and memoization and recursion. Blimey. Assignment. The creator of Doc2Doc is a huge fan of palindromes for some nerdy reason. Add a feature to check if a word is a palindrome. Import LRU cache function from FuncTools module. Use it to decorate the incomplete is palindrome function. So at LRU cache, like that. Complete the is palindrome function. It takes a word input. It takes input word string and returns true if the word is palindrome, such as race car, or false otherwise. Try to use recursion. Check the outer characters first, then move inwards until you reach the base case or find the word is not a palindrome. Oh. Right. So, palindrome. Try to use recursion. It takes an input word, string, and returns truth if the word is a palindrome, such as race car. Palindrome is just the same forwards and backwards. Or false otherwise. Try to use recursion. Check the outer characters first, then move inwards until you reach the base case or find the word is not a palindrome. And just to check, palindrome is a word, number, phrase, or other sequence of symbols that reads the same backwards as forwards. Do not have a light mode on Wikipedia. There we go. So, what are we going to do? So, I guess, how do we check if it's same back to front? What are we going to use recursion for? I mean, I think there's a lot of different ways. The way I was thinking, although it doesn't sound very smart, is, I guess, to get the first and the last letters, check if they're the same. If they are, keep going. If they're not, then just return false. Something like that. It feels a little bit weird. If we loop it using a palindrome, so what's the base case? I guess we're doing that way is, so if length of word is less than 1, less than or equal to 1, then return true. That's our base case. And then I guess if so then we go characters, and it's going to be list like word split, and then I guess if chars 0 is equal to chars minus 1, then is palindrome, and then then we do word I guess we'll do like string dot join chars and it'll be 1 colon minus 2. Else return false. Something like that. Oh, kind of got it. Ooh, almost got it. Why is this one fell? Potato. And I'm going to print. Can't believe that worked. I wonder if there's a better way of doing it than I'm doing it. See, you just put your mind to it, and you find out. Let's only print once. Oh, hold on. Python string to car array. Oh, don't you split it? Just literally wrap it in a list. Dick. Oh, did I just do it? No way. I feel like I fluked it, but I did it. Hold on. Submit. Whee! Let's see how they did theirs. Kind of done the same thing. It's less than 2. First word, last word. First not equal to last. I just did mine straight up. That was a bit neat to read, I guess. Return false. Yeah, there's more readable and neater. Cool. So we're on to the last bit. And there's not that many in here. Cool. Yes. Yes. Come on. Come on. I'm going to get this done tonight. Come on, guys. Come on, give us a W in the chat if I finish this tonight. Yeah? Give us a W. Some types. So, I have no idea what some types are. Let's find out. Never heard of them. Some types. Remember when I said pure functions are my favorite part of functional programming? Well, some types are a close second. A sum type is the opposite of a product type. This Python object is an example of a product type. The total number of combinations a man can have is 4. The product of 2 times 2. Yep, okay. If we add a third attribute, perhaps has blue eyes boolean, the total number of possibilities multiplies to 8. But let's pretend that we live in a world where there are only 3 types of people that our program cares about. Dateable, undateable, maybe dateable. We can reduce the number of cases our code needs to handle using an admittedly fake, Pythonic sum type with only 3 possible types. Person, yeah. I've forgotten classes in Python, but yeah, instance syntax with self, name and the init. Dateable is a type of person, maybe dateable type of person. They're all types of people. Then we can use the isInstance built-in function to check if a person is an instance of one of the subclasses. It's a clunky way to represent some types, but hey, it's Python. Okay. Yeah. Some types, as opposed to product types, which have many, often infinite combinations, some types have a fixed number of possible values. To be clear, Python doesn't really support some types. We have to use a workaround and invent our own little system to force it ourselves. Assignment. Whenever a document is passed by doc to doc, it can either succeed or fail. Whenever a document is passed by doc to doc, it can succeed or fail. In functional programming, we often represent errors as data, e.g. the pass error class, rather than raising exceptions because exceptions are side effects. This is a standard Python practice, but it's useful to understand from a functional programming perspective. Complete the passed and pass error subclasses. The pass represents success. It should accept a doc name, string, and a text string, and save them as properties of the same name. Takes doc name, text string, and saves them as properties of the same name. What? And a text string, and save them as properties of the same name. All right. Okay. So, I kind of don't remember this. I think it's self dot doc. It's the name equals doc name, and it's text like that. Represents a failure. It should accept a doc name string and an error string and save them as properties of the same name. So okay. Is that it? Yeah. That was it. The test suite uses is instant function. See if any code based on base class type. Don't really understand that, like that lesson for some types for that one. Doesn't really make sense. Uh-oh, you guys are going to have to listen through the mic again. I have not figured out headphones for this setup yet. Whoops. Good thing I looked down because my battery is about to run out. Better get that plugged in quick. Quick. It's on 7%, could turn off any second. Oh, crisis averted. Whew. Oh, wait. Charging? Yes. Oh, thank goodness. Okay. Doing the admittedly weird class in is instant thing works, but it turns out there's a better way in some cases to represent a fixed set of values, but not store additional data within them. Enums are the way to go. Now, who likes enums in TypeScript? Nobody. So, see if they're any better in Python.
Enums are one of the best things to happen in programming, and that's including the release of the best operating system of all time, Windows Vista. But before we talk about enums, let's brush up on a little bit of category theory. And despite the word theory being added to scare non-academics, it's really not too bad. In programming, types are how we categorize things. For example, this partner class contains two variables, both of which are Boolean types. So the partner type actually contains other types. And this is common when working with collection types like lists, tuples, and classes. The interesting thing about this partner class is that it really has four possible combinations of values. Studies finance can be true, as trust fund also true. Studies finance true, as trust fund false. Studies finance false, has trust fund true. Studies finance false, has trust fund false. And that seems manageable, but what happens if we add a third field? Well, if it's also a Boolean, then the number of possibilities actually jumps up to 8, because we have to multiply 4 by the available combinations again, which is 2, getting 8 possible total combinations. If we add another, we get 16, and if we go up to 5, then we get a total number of 32 combinations. And if we add a string into the mix instead of a Boolean, then the number of total possible values essentially goes up to infinity, because a string can contain any number of combinations of characters. Now, this is where the term product type and sum type come into play. They're also sometimes referred to as algebraic data types, just to scare the non-PhDs. The partner class is a product type because the total number of possible combinations of values is the product of the number of fields, right? 2 times 2 times 2 times 2 times 2, however many Boolean fields we add in there. But product types are very interesting. Almost everything is a product type by default. Lists, tuples, and classes with, a number of properties. And the problem is that product types result in many possibilities. And even primitive types like strings and integers have the same problem. When you have a string type, you don't know if that string value contains the entire text of the novel Moby Dick, or the string Hello World, or the empty string. There's so many possible combinations that could be stored in that type. And that makes them hard to work with. Right? When you write a function that accepts one of those types as a parameter, you have endless if-else statements and switch cases and fallbacks to handle all of the different possibilities that could arise when your function is called with different values. That's where some types come into play. They're just types where the number of possibilities is limited to a finite set. A Boolean is a good example of a sum type. It has two possibilities, true and false. When you're working with a Boolean, all you have to think about is whether this variable is true or false. Okay, so now we can finally talk about enums. Enums are another sum type, like a Boolean, and really, I like to think about them as kind of extended Booleans. For example, let's say we want to write a button class, and in its button class, we want to specify that it can be one of three colors. We could have the buttons constructor accept just a string to define which color it's going to be, and we'd accept either the string red, the string green, or the string blue. Now, the problem is that our button class now needs to take into account that whoever's creating a new button could pass in any string, right? They could pass in the string teal, or they could just pass in a misspelled blue, and we need to handle both of those cases. The better option is to use an enum. And at least in Python, the way you can define an enum is using the enum package. You pass in the name of the enum, in our case, we'll use color, and then the possible values that are valid in this new type. So in our case, red, green, and blue. Now in code, if we use color.red, it will work. It will resolve to the color red. And as far as the color type is concerned, everything will work smoothly. But if we try to use a color that was not specified when we created the color type, like teal, the Python interpreter itself will actually throw an error. So now the language itself will raise an exception if we try to use the wrong value. And that means that in all of our code, we no longer need to have all of these if-else statements checking and making sure that the variable maps to a valid value. Right? There might be 10 different places in code that have to check the value, and we don't want to rewrite all that code. In a language like Python, the interpreter will yell at us when we run the code if we ever use an invalid value in an enum type. But in statically typed languages, like a lot of the compiled languages, like Go or TypeScript or C, we'd actually get the errors either at compile time or even better, right in our editor telling us that those values are not allowed for that type. That said, enums are still useful even in a language like Python. Python's not statically typed, so it does mean we'll have to actually run the code to see the type errors, but at least the valid values, red, green, and blue, are defined when we create the enum type. So there's a single place to reference, so we as developers can see what colors are valid types, and we won't have to keep redefining it every time we check the value.
Huzzah. Seems like they're better than TypeScript ones. So, let's say we have a color variable that we want to restrict to only three possible values, red, green, and blue. We could use the plain old string to represent these values, but that's annoying because we have to remember all the valid values and defensively check for invalid ones all over our code base. Instead, we can use an enum. This works, prints color red. There's an exception. Now color is a sum type, at least as close as we can get in Python. There are a few benefits. Color can only be red, green, or blue. If you try color teal, Python raises exception. There is a central place to see the valid values of a color. Each color has a name, red, and a value, e.g. 1. The value is an integer and is used under the hood instead of the name. Integers take up less memory than strings, which helps with performance. Assignment. Create an enum called doctype with the values PDF, TXT, and docx, MD, and MD. So create an enum called doctype. So doctype equals hold on. So what we're going to have, PDF. What else is it going to have? TXT, docx, MD, and then HTML. Whoops. Happy days, oh, happy days. Oh, we are near the end. Look how close we are to the end. We're almost at the end. Sum types. Unfortunately, Python does not support sum types as well as some other statically typed languages. Python does not enforce your types before your code runs. That's why we need this line here to raise an exception if a color is invalid. Yep. In a language like Rust, we could write the same thing like this. So function color to hex takes a color and outputs a string. Match color colon green gives you this, like this to string, this string, this string. That's quite nice. Nice format. Notice that there isn't a case for an unknown value. That's because the Rust code will fail to compile, a step that happens before the code runs at all, if the color is a different value. This static enforcement is a huge benefit of some types, and it's a shame we can't get that in Python. Which language does not support proper sum types? Python. Same thing again. Why are sum types useful? You have to run your code to see if you've handled all possible cases. You can know before you run your code that you've handled all possible cases. They ensure that your variables can hold any type of value. This one. You can know before you run your code that you've handled all possible cases. Oh. Boot.dev, are you okay? You've frozen. Refresh that. Yep, correct. Move on to the next one. Lesson 5, and then 2 more. Come on, we're almost there. Match. Let's take another example of the enum from the previous lesson. Working with enums. Python has a match statement that tends to be a lot cleaner than a series of if, else, elif, statements when we're working with a fixed set of possible values, like a sum type, or a more specifically an enum. So match color case this. Oh, match. I was looking for that the other day. I thought it was this is a switch statement basically. I couldn't find it. I was like constantly just thought it was a switch statement in Python, but it's not. Default case invalid color, return that. If you have 2 values to match, you can use a tuple. Okay, nice. The value. Me. Got 2 challenges and it's like throwing this at us. The value when compare is set after the match keyword, which is then compared against different cases / patterns. If a match is found, the code in the block is executed. Assignment. Complete the convert format function using the enum doc format. It should support 3 types of conversions. MD to HTML. Okay, so we're going to have match. And how's that go again? Match color. Match. From format and to format. So yep, colon like all things. So colon case. What was the syntax again? Like that, yeah. So from MD to HTML, assume the content is single H1 to, oh my goodness, it's going to be. Okay. Okay, so assignment from MD to HTML. So I guess doc format dot MD, doc format dot HTML. Why is there no autocomplete? Oh well. So if they match, assume the content is a single H1 tag in Markdown syntax. It's a single string representing a line, replacing the leading hash with a H1 and a H1 to the end. Okay, so return so it's going to be H1 like that. And it's going to be f string like that. It's going to be content dot l strip that, and it's hash. Unmatched. Python l strip. Like a trim. Python remove white space from string. Strip. Do like L strip like that. That work? Okay, like that. Text to PDF, so we're going to have case like this, doc format dot txt, and then doc format dot PDF. And what's saying for this one is we're saying simply add PDF tag to beginning and end of the content. Notice the spaces between PDF tags and the content. Okay, so return f string. That's going to be PDF, 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 and it's going to be like that. It's going to be content. Okay, from HTML to MD. So there's another one. So case doc format, sorry, HTML to doc format dot MD. And then we're going to return another f string. Replace h1 tags with the blah 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 blah. other conversions. If the input is invalid, raise an exception. So I guess case underscore colon, is it like that? Yeah. Then we're going to raise exception invalid valid type. Let me put in like this. Like that. Has to be single quotes like that. Weird. Submit. Ah, one failed. I just strip it like that. Oh no, still failing. Still failing. Actual. Dot R strip. There's something not right about that. Python chain strip functions. Stripped content. So stripped content goes that. Content first. Strip content final. What is with it? Whoops. Still failing. What the heck? Why is it failing? What am I doing wrong, Boots? Pretty sure this is it, right? No, it does not like that. So I don't think it's anything to do with this. Hmm. Oh, I'm a dummy because of that. So it would have worked before. I was just being an idiot. Well, we're not done yet because we're going to do the 2 challenges that are left. Not done yet. No, we're not done yet. Come on. Not yet. Not yet. We finish this. Come on, we finish the fight. Master Chief style. Come on. Oh, please don't take forever, these ones. Export CSV. Doc should be able to prepare and export CSV file of whatever data you input. Comma-separated values are ubiquitous text format that allows for information to be structured in a table. There is usually a header row followed by data rows. Within rows, items are separated by commas. Complete the get CSV status function. It should use a match case statement to select the correct response depending on the status of the export operation. Create functions to handle each operation as follows. Pending. Okay. So handle pending. Pending. Return a tuple with the string pending and the data converted from a list of lists of anything to a list of strings. Oh my goodness. Return a tuple with the string pending and the data converted from a list of lists. List of, and it's called lists. Return processing. Oh no, hold on, pending. And the data converted from a list of lists of anything to a list of strings. List of lists. Okay, so we're going to do match. That's going to be case. That's going to be CSV export status dot pen. Why is it not all complete? It's really kind of annoying. Pending. Return handle pending data. Case if the input status is none of the above, raise exception, unknown export status. So raise exception, unknown. I'm just going to copy that because I hate typing the word unknown. Unknown. So we're gonna, I guess, map that. So map, and we do lambda list. Oops, lambda list calls, and then what we're gonna do for item in list. Sister item, something like that. Hold on, Python lambda function loop list. Oh, this gets ugly quick, doesn't it? Ugh. Like that. So we do list and then map lambda nested, it's called list equals, and then the thing of list item Anyway, let's get pending working first, because blimey. So we map over the list of lists. Yeah. And we get I guess we can't call it that, can we? Like, so nested skull list. Is that better? Yay, it's because we use the keyword list. Right, so the next one. So processing, return tuple of string processing. So we're going to have another one, define handle, it's got processing. So lists of lists of strings. It's going to return a tuple of processing and then it's going to return converted from a list of lists to strings into one string in CSV format. So list to CSV string CSV string list. Oops. So list of strings. So for each list of strings, combine the strings with join with commas in between to form a row. So we do map lambda nested underscore list, and the thing is going to be a list of strings. And what we're going to do, we're going to for each list of strings, combine the strings with join with commas in between to form a row. So string dot join nested list. What is this? Yeah, nested list, and just see what it does. List join it could be like this, then like that. Whoops, we forgot to put the case. So case CSV export status dot processing, and then return that data. Commas in between to form a row. For each row string, combine the strings with join. Join That's going to be like that. So we've got 2 of them passing. Huzzah. Then we have the success. So success, and then we're just going to return the data as is. Success, like that. Yep, and then failure. Return a tuple with the string unknown error retrying, and the data after it is being prepared and processed into a CSV string by combining the steps for pending and processing. So this. And we are going to handle pending, handle processing. So it's going to be not sure which way around. We'll do like handle processing like this. By combining the steps of pending and processing. Return a tuple with the... Whoops, that's on the wrong line. Okay, boom, shakalaka. Oof, that was a bit of a doozy. Blimey. Oh, I'm feeling it now. Lee, I've been struggling hard with the project after finishing functional programming. Trying to work on it while maintaining a streak is driving me nuts. I'm looking forward to seeing you work through it. Cheers, Lee. Yeah, if you join in, so like next week, I guess we're going to finish this tonight for definite. If it's the last thing I do. So are you talking about the which one are you up to? You up to module 8, or is it the personal project 12? What do you say? So functional project trying to work. The project. So is it the build static site generator, the one you're stuck on? I'll be doing that one next week. So we'll see how it goes. But yeah, tune in, follow along. Hopefully maybe I can give you some help, like as I'm going through it and like figure it out myself. We can kind of do it together. That'd be cool. But last one for tonight, because my brain is getting drained. Yeah, number 8, static site generator. Cool. Well, we will be tackling that one next week as well. So if you tune in, I'm just checking when I'm going to be streaming next week, just so I don't tell everybody the wrong day. So next week, I think it's just going to be Thursday, actually. Just Thursday next week. Yeah. Okay. So just next week, yeah. So tune in next Thursday, and we'll try and figure it out, depending on how far through you are, because I might not get that far. Right, so edit document, last one for tonight. Doc2Doc should be able to track changes in documents. Tracking changes is important for undoing and redoing edits. Some editors save changes and some file formats do as well. Assignment, complete the handle edit function. It takes as an input a document. 2-day streak. Oh, coding daily. Yeah, I can't do that. I can't. But never mind. You can see your GitHub account and add the repo webhooks. You're saying so project streak. Yeah. Doesn't matter. I'm not worried about the streak. But you go for it. Go for the streak if you can. That's impressive. Complete the handle edit function. It takes input of document, an edit type enum, and edit dictionary. It should use a match case statement to select the correct operation depending on the edit type. Create a function to handle each operation as follows. So new line. So I'm going to start with match. And it's saying it should match use case to select the correct operation depending on the edit type. So edit type, match case edit type, and then case new line. So case edit type dot new line, and then what we're going to do, new line, use the edit dictionary. Use the edit dictionary to modify and return a copy of the document. The edit dictionary will only contain a line. Oh, got my brain now. Use the edit dictionary to modify and return a copy of the document. The edit dictionary will only contain a line number, key and integer value, 0 indexed. Add a new line /n at the end of the line of the document corresponding to the line number. I don't think I even understand what that's saying. I'm just looking at it thinking, Hold on. It takes a document string, edit type enum, and an edit dictionary. It should use a match case statement to select the correct operation, blah, blah, blah. So new line. Use the edit dictionary to modify and return a copy of the document. The edit dictionary will only contain a line number, key, and integer value, 0 indexed. And add a new line at the end of the line of the document corresponding to the line number. Use the edit dictionary to modify and return a copy of the document. Document's a string. The edit dictionary will only contain a line number, key and integer values in index based. Add a new line /n at the end of the line of the document corresponding to the line number. What the blooming heck? Right, and then edit. Let's see what this does. I gotta see what's going on here. Because the Lord knows what be going on. Printing. Ugh. Come on, let's see what it's doing. Dear manager is the document. This is all the document. And the edit line number. Okay. So document so copy equals document dot copy, and then return document copy. See that for now. See what it does. Object has no attribute copy. Well, strings are immutable, aren't they? So I guess it doesn't really matter. Documents. Okay, so so I guess we do lines equals document dot split. It's a string, isn't it? So you can't. Yeah, I can do that. So like that, and then print printing lines. So new line only contain line. So I printed that out before, and it was edit. What did it look like? Return lines. That is going to be Python insert into list. Dot insert, and then what was it, like the item in the element? So like that, and then it's going to be like that. Is it close? Come on, a new line. So it's expecting, dear manager, I'm outraged. My car warranty is an total disaster. Admits to be fix this right now, sincerely, blah. So I've got, dear manager, I'm outraged. My car warranty is a total disaster. Fix this right now, sincerely. So what's wrong with that? Right, going to move on to the next one. I'll come back to it. Substitute. Use the edit dictionary to do the base case. So case, just call it that. Exceptions to the edit type is none of the above. Raise the exception. Raise exception. It's going to be unknown edit type. And right, we're going to do substitute next. So case, whoops, edit type dot substitute. Use the edit dictionary to modify and return a copy of the document. Oh, not again. Edit dictionary will contain a insert text key and string value, a line number key and integer value, a start key and integer value, and an end key and integer value. Oh my goodness. Substitute the insert key into the line of the document corresponding to the line number between the start and the end indexes. Oh my goodness. Right. Oh my goodness. Ugh. Brain is turning to mush. Oh my goodness. I think we need to crack this one before we can carry on, because let's get the substitute one. Try and get substitute one, because this is a real pain. So use the edit dictionary to modify and return a copy of the document. The edit dictionary will contain an insert key and string value, a line number key and integer value, a start key and integer value, and an end key and integer value. Substitute the insert index into the line of the document corresponding to the line number between start and end indexes. So line number 1, 2, 3, 4, 5, 6, 7. What's the difference between that and that? 1, 2, 3, 4, 5, 6, 7. Right, let's get substitute working. So substitute, insert text key, a line number key, so same thing as this. So chosen line equals that, and then Python substitute part of string. By index. Chosen line equals that. Chosen line equals chosen. Oops. And it's going to be insert underscore text. And this is going to be edit start. It's going to be Wow, that is ugly as heck, but it works. Very ugly. Edit type dot insert. Insert edit dictionary modifies chain copy, blah 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 blah. And the edit dictionary will contain insert text key and string value, line number key, into value, and a start key into value. Insert the line, and blah blah blah. So it's a bit bigger. So insert sincerely Karen. Right. I think we're gonna get delete working, and then I'm just gonna ask to get the new line, the new line one, because it's gonna be bugging me. I think, to be honest, we could have made it some functions to make this a little bit neater, but I'm running out of time here, so I'm just kind of going for it. Ugly first, then pretty later. So line number, and then there's no edit thing to insert. And that line number is going to be the lines edit start plus lines, and just see what that does. Failed. Submit. Oh, it all works apart from one, and it's the basic, say the basic one, the new line one. Is it because of that? Plus one? Nope. What's wrong with this one? So, new line. Line number 7, expected. Dear manager, I'm outraged, blah, 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 blah. And then the difference is, dear manager, blah, 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 blah. Looks the same. Right, come on, Boots, help us out. Right. I'm I'm tired. I'm tired, and my brain is mush. What's wrong with this, Boots? Come on. I understand being tired. Carefully walk through your code and see what might be going wrong. Looks like your implementation. I notice a few issues with how you're handling different types. For a new line, you're inserting a slash new line as a new line at a specified position, but based on instructions, you should be adding a new line at the end of the specified line number. Oh, thank goodness. Is that it? Oh, oh, thank God. Oh, thank you, Boots. Thank you. Right. Thank you, Boots. I'm not going to read the rest of what you just said because I'm kind of done. Let's see what the solution looked like and see how bad mine was. Yes, they split out into new functions. I thought so. So new line. Yep, so they're kind of doing what I was doing. Yeah, they basically just what I did, but split it out. Yeah, yep. Did that. Yeah, insert document, text line number style. Oh, whoa. Oh, they can reuse that substitute function. Document insert line number start end. Well, mine was nowhere as sophisticated as that, but I'm terrible at Python, so there we go. So, boom. We are done. There is now nothing else to do on that. Dashboard. Yep, that's the next one up. So we finished. And in fact, let's claim our victory. Yeah, it's whatever. My calls right now. I'm really bothered about these ones. This one I am bothered about. Woo! Let's get a picture. Get that picture. Nice. And claim that 7,000 XP. Woo! Yeah, I love functional programming, but I've never covered it from the ground up. This is the perfect course to learn it all. A bit tricky for beginners, but worth the challenge to get through. Can't fault it. Can't fault any of these courses, to be honest, apart from being a little tricky. Can't really fault it, to be honest. So let's get this, download it. Let's share it to LinkedIn. Why don't you? Am I even logged into LinkedIn this? Yeah, I am. Woo! So Python, functional programming, how do I zoom out the? Want a bigger image? Show me a bigger image. That one. So. Woo, got another thing for the. So go to this, and then what is it? Change that. That, and add a photo. That one. Next. Yeah. Another one bites the dust. Module 7, was it? Module 7 of at Boot.dev. Hold on, no, not that. I don't know how to do emojis on this. Want to learn everything from the ground up. I learned plenty of things I've missed along the way, like just like implementing recursion with more comfort. Okay. I think I turn the volume off. Post. Please. Pretty sure it's posted. Yep. So there we go. No one bites the dust. It is gone 11 o'clock, so we're gonna cut it there for now. But thanks everyone for tuning in. Hope you had fun during that, watching me struggle. It was kind of hilarious. And yeah. Lee, I'll see you next week on stream if you're still around. Next Thursday, we'll get into the project, and hopefully, if you're around, we'll be able to help you out a little bit with that. So, have a good night. Thanks very much for watching. If you're coming back from the future, let me know where you got the time machine. And